Today we will discuss about the theory of Big Bang. Theory is the leading explanation about how the universe began. At its simplest, it says the universe as we know it started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. Because current instruments don't allow astronomers to peer back at the universe's birth, much of what we understand about the Big Bang theory comes from mathematical formulas and models. Astronomers can, however, see the echo of the expansion through a phenomenon known as the cosmic microwave background. While the majority of the astronomical community accepts the theory, there are some theorists who have alternative explanations besides the Big Bang, such as eternal inflation or an oscillating universe. The phrase Big Bang theory has been popular among astrophysicists for decades, but it hit the mainstream in 2007 when a comedy show with the same name premiered on CBS. The show follows the home and academic life of several researchers, including an astrophysicist. The first second, and the birth of light in the first second after the universe began, the surrounding temperature was about 10 billion degrees Fahrenheit 5.5 billion Celsius according to NASA. The cosmos contained a vast array of fundamental particles such as neutrons, electrons, and protons. These decayed or combined as the universe got cooler. This early soup would have been impossible to look at, because light could not carry inside of it. The free electrons would have caused light, photons, to scatter the way sunlight scatters from the water droplets in clouds, NASA stated. Over time, however, the free electrons met up with nuclei and created neutral atoms. This allowed light to shine through about 380,000 years after the Big Bang. This early light, sometimes called afterglow of the Big Bang, is more properly known as the cosmic microwave background. It was first predicted by Ralph Alpher and other scientists in 1948, but was found only by accident almost 20 years later. Images peering back to the Big Bang and early universe are Arno Penzias and Robert Wilson, both of Bell Telephone Laboratories in Murray Hill, New Jersey, were building a radio receiver in 1965 and picking up higher than expected temperatures, according to NASA. At first, they thought the anomaly was due to pigeons and their dung, but even after cleaning up the mess and killing pigeons that tried to roost inside the antenna, the anomaly persisted. Simultaneously, a Princeton University team, led by Robert Dick, was trying to find evidence of the CMB, and realized that Penzias and Wilson had stumbled upon it. The teams each published papers in the Astrophysical Journal in 1965. Determining the age of the universe. The cosmic microwave background has been observed on many missions. One of the most famous spacefaring missions was NASA's Cosmic Background Explorer, COBE, satellite, which mapped the sky in the 1990s. Several other missions have followed in COBE's footsteps, such as the Boomerang experiment, balloon observations of millimetric extragalactic radiation and geophysics, NASA's Wilkinson Microwave Anisotropy Probe, and the European Space Agency's Planck satellite. Planck's observations, first released in 2013, mapped the background in unprecedented detail and revealed that the universe was older than previously thought, 13.82 billion years old, rather than 13.7 billion years old. Related, how old is the universe? The Research Observatory's mission is ongoing and new maps of the cosmic microwave background are released periodically. The maps give rise to new mysteries, however, such as why the southern hemisphere appears slightly redder, warmer, than the northern hemisphere. The Big Bang theory says that the CMB would be mostly the same, no matter where you look. Examining the cosmic microwave background also gives astronomers clues as to the composition of the universe. Researchers think most of the cosmos is made up of matter and energy that cannot be sensed with conventional instruments, leading to the names dark matter and dark energy. Only 5% of the universe is made up of matter, such as planets, stars, and galaxies. Gravitational waves controversy. While astronomers could see the universe's beginnings, they've also been seeking out proof of its rapid inflation. Theory says that in the first second after the universe was born, our cosmos ballooned faster than the speed of light. That, by the way, does not violate Albert Einstein's speed limit, since he said that light in 2014 Astronomers said they had found evidence in the CMB concerning B modes, a sort of polarization generated as the universe got bigger and created gravitational waves. The team spotted evidence of this using an Antarctic telescope called background imaging of cosmic extragalactic polarization. We are very confident that the signal that we are seeing is real, and it's on the sky, lead researcher John Kovac, of the Harvard-Smithsonian Center for Astrophysics, told Space.com in March 2014. But by June, the same team said that their findings could have been altered by galactic dust getting in the way of their field of view. If you like my video, please subscribe our channel. Thank you.